We're going to be looking at the agenda question number 3 for chapter 4. Let's take a look at what we're trying to do here on the whiteboard. So they want us to find the slope and the y-intercept for each of the following questions. And before we do that, let's talk a little bit about what we mean by slope and intercept. So we're still graphing things on this x and y axis concept. This is still our x and our y. And let's say we had a y-intercept of 3. So 1, 2, 3. The y-intercept, all that means is where does the line go through? In this case, 3, if the y-intercept is 3. And the slope is where does the line go after it goes through the y-axis? Where does it go? Basically in this direction. So if the line goes up, we're dealing with a positive slope. If the line goes down, we're dealing with a negative slope. If the line was horizontal, the slope would be 0. And if the line was vertical, if I can get it to go vertically, doesn't want to at all, okay. If the line was vertical, then they'd say the slope was either infinity or undefined. So that's what they mean basically by the slope, but they'll also refer to the slope as rise over run. Which more technically means the vertical change divided by the horizontal change. And so if they told us the slope equaled, equal 2, what we would put it over 2 over 1, and we'd basically say that for every 1 the line went in this direction, it would come down 2. Oh no, sorry, it's a positive slope. It would go up 2, a positive 2. And if it went over another 1, it would go up another 2. Be better if I actually got a straight line here. So that's what a slope of 2 would be. If they told us the slope was equal to, say, slope equal to 2/3, then we don't need to put it over 1. It's already in the form of rise over run. So we'd have for a horizontal change of 3, so let's say 1, 2, 3, the line would be going up 2. So the line would look like this. If we did another 1, 2, 3, so 1, 2, 3, the line would go up another 2, and we'd be like here. So if they give you the slope, if the slope turns out to be just a positive number or a negative number, put it over 1 to sort of interpret what it's doing. If it's already a fraction, then you don't need to put it over 1 because you've already got a number for the rise and a number for the run, or a number for the vertical change and a number for the horizontal change. So that's basically what we mean by the concept of intercept and slope. The intercept, think of the intercept as where the line starts, and think of the slope as the direction that it goes in. And when you're trying to interpret the slope, think of it in terms of rise over run, or vertical change over horizontal change. So, having looked at that, let's actually look at one of these equations. So, they've given us an equation of 2x minus y equals 4, and this equation in the form of a something times x plus or minus something times y equals something else. This format of the equation is referred to as the standard form. And we'll use this standard form for various things, but in this case, what we want is something called the the slope-intercept form. And this form of the equation looks like this: y equals ax plus b, or these can be reversed. It can be y equals b plus ax. Just depends on what the equation looks like after you solve it. But what's important is the number sitting on its own, in this case b, equals the y-intercept, and the number multiplied by x, usually referred to as the x coefficient, is the slope. So what we have to do is algebraically manipulate this to get it into this form. So let's do that. We've got 2x minus y equals 4. This x term has to leap over. So we've got negative y equals 4 minus 2x. And then we have to multiply through by the negative 1 to get rid of this. We have y equals negative 4 plus 2x. And now we can easily see the 1 sitting on its own is negative 4. So negative 4 equals the y-intercept. And 2 equals the slope. So in most cases, when you ask for the slope and the intercept, we don't have to graph it, but let's graph this one just to see the relationship between what we've just calculated and the line that we're actually looking at. So let's take this original equation and find our 2 points, 0 and 0. So when we go 2 times 0, take away y equals 4. So we get negative y equals 4. So y equals negative 4. So negative 4. We've got one ordered number pair. And when we go 2x take away 0 equals 4, becomes 2x equals 4, and x equals 4 divided by 2, which equals 2. So we have 2 points on this line. Let's graph it. When x is 0, y is negative 4. 1, 2, 3, 4. So that's 1 point on the line. And when y is 0, x is 2. So 1, 2, right on the line. And we want to put a line through these. Look pretty well like that, I guess. And so now that we have the line there, let's interpret that in terms of our slope and intercept that we found. Well, we found the y-intercept to be negative 4, and indeed, that's where we are at negative 4. The slope's a little more difficult to interpret, but says we have a slope of 2. So slope equals rise over run. And as it's just a number, 2, we can put it over 1. And so what we're saying is that for every 1 we go in this direction, we're going to go 2 up. So we went 1 over and 2 up. And if we go 1 over, we'd go 2 up. So that's what we mean by the slope of 2. For every 1 we go in the horizontal direction, we go 2 in the vertical direction. So this line definitely has a slope of 2. So that's basically all we need to do there. We can see the y-intercept and the slope. So let's try the next one. So we're given an equation of 3x plus 4y equals negative 2. We can see this is still in the standard form, so we're going to manipulate it into the slope-intercept form. 4y equals negative 2 minus 3x, and y equals negative 2 minus 3x, all divided by 4. So we've isolated the y, but we've got to sort out this nonsense. So y equals negative 2 over 4, take away 3 over 4x. And so we can now see our intercept is the number on its own, which is negative 2 over 4. But we can't leave this without simplifying it. It's got to be negative 1/2. And the slope equals negative 3/4. And that's all we need to find. The slope, negative 3/4, and the intercept negative 1/2. So let's do another one. They've given us y equals 2/3 x, take away 7. And in this case, it's already in the slope-intercept form. So the number sitting on its own, negative 7, is the intercept. Equals negative 7. And the slope equals 2/3. That's all we have to do because it's already in the slope-intercept form. Let's try the next one. So this is a little bit annoying because they've given us y equals 8. We could go y equals 8 plus 0x, and that would make some sense because the number on its own here, the y-intercept, equals 8, and the slope equals 0. This makes a little bit more sense if we graph it. Sometimes it's worth graphing these things to make sense out of what they're trying to tell you. If y equals 8, then we'd go 1, 2, 3, 4, 5, 6, 7, 8. But it doesn't matter what x equals. So we're really dealing with a horizontal line. And that's what they, oops, where did our line go? Disappeared altogether. Try that again. So this is our equation. Y equals 8. We can see the intercept is indeed 8, and there's no slope to it. So we would report the y-intercept as being 8, the slope being 0. Let's look at the next one. This one is even more annoying because there's no y in the equation. They've just given us x equals 5. So in a situation like this, again, the best thing to do is to graph it to see what the hell they're up to. We have x and y. X equals 5. 1, 2, 3, 4, 5. And if x equals 5, it doesn't matter what y equals. X just equals 5. That's what they're telling us. So this is the equation x equals 5. But we can see there's no y-intercept. So we would just have to report that. So a bit of a trick question, as they've asked us for the y-intercept. There's no y-intercept. And the slope here could either be reported as being infinite, or I think they would call it undefined. But it's just a vertical line. So that one really has no y-intercept and no slope. So that's the best we could do, just report it in that way and hope that that's what they were expecting us to come up with. So let's call it quits there with that question.